We need to find the degree of the differential equation d cube y by dx cube whole power 2 by 3 plus 4 minus 3 times of d square y by dx square plus 5 times of dy by dx. Since we have first order, second order and third order derivatives, and since the power of third order derivative is 2 by 3, which is not an integer, so let us rewrite the equation d cube y by dx power 3 whole power 2 by 3 is equal to 3 times d square y by dx square minus 5 times dy by dx minus 4. And then now cubing on both the sides. So we get d cube y by dx cube whole square is equal to 3 times of d square y by dx square minus 5 times of dy by dx minus 4 whole to the power 3. So in the expansion you will be getting the second order and first order power 3, but here the highest order is third order derivative, that is d cube y by dx cube, and the power of this is 2. So we can consider degree of given differential equation is equal to 2, since 2 is the power for this highest order. The other side we have only second order and first order and constant terms, so we will be getting, so we need to consider only the highest, the degree of the power of the highest order derivative, that is 2. So option 2 is the answer. So what is the solution of dy by dx plus 2y is equal to 1, satisfying y at 0 is equal to 0, means when x is equal to 0 the y value is 0. So we can write here dy by dx is equal to 1 minus 2y, or we can write dy by 1 minus 2y is equal to dx. And now integrating on both the sides, so we get 1 upon 1 minus 2y dy is equal to integral of 1 dx. So we know integration 1 upon x is log x, but here log of 1 minus 2y divided with the coefficient of y is negative 2, so we can write minus 2 plus, or we can write other side constant, is equal to integration of 1 dx is x plus c, or we can write log 1 minus 2y, or 1 upon 2, or minus 1 upon 2 is equal to x plus c. And since it is given when x is equal to 0, y is equal to 0, y of 0 is equal to 0, which implies minus 1 by 2 log mod of 1 minus 2 into 0, which is equal to 0 plus c. So we can write here minus 1 by 2 log 1 is equal to c. Log 1 value is 0, so we can say c is equal to 0. And hence the equation we can write minus 1 by 2 log mod of 1 minus 2y is equal to x plus 0. Or we can write log mod of 1 minus 2y is equal to, so we can write here minus 2x, or 1 minus 2y is equal to, removing logarithms, we will get e to the power minus 2x, or we can write 1 minus e to the power minus 2x is equal to 2y, or finally we can say y is equal to 1 minus e power minus 2x upon 2. So y is equal to 1 minus e power minus 2x upon 2, which is our option 1, option A. We need to find the solution of differential equation and also represents what type of conic, like circles or straight lines or ellipse or parabola. So given differential equation 2x into dy by dx minus y is equal to 3, which can also be written 2x into dy by dx is equal to 3 plus y, or we can write dy upon 3 plus y, or 2 times, is equal to dx upon x, and integrating on both the sides. So we get integral 2 times of 1 upon 3 plus y dy is equal to integral 1 upon x dx. And here we can add 2 times integration of 1 upon x dx is log x. So we can add 1 upon 3 plus y can be taken as log of 3 plus y, and divided with the coefficient of y is 1 here, is equal to log x, and we can write the constant also log c, because both the sides logarithm is there. So let us use log c. So we can also write this is log 3 plus y whole square is equal to log xc. Log a plus log b is log ab. Log a plus log b is equal to log ab property we are using, and log m log a is equal to log a power m. So on both the sides same with the logarithm, let us consider the base is e here. So we must consider y plus 3 whole square is equal to xc. So it can be represented like y minus k whole square is equal to 4a into x minus h, which is a parabola. So we can write y minus of minus 3 whole square is equal to 4 into c by 4 times of x minus 0. So whose vertex of the parabola is 0 comma minus 3. And the focus is here a is equal to c upon 4, which is representing a parabola. So we can mention that this equation represents a family of parabolas depends upon the constant c. So option D is the answer. The solution of the differential equation dy by dx plus y upon x is equal to sin x. So which is in the form of dy by dx plus p of x into y is equal to q of x, whose integrating factor e to the power integral p of x dx, and the general solution y into integrating factor is equal to integral of q of x into integrating factor dx. So let us find integrating factor here. If is equal to e to the power of integral 1 upon x dx, which is e to the power of log x, and we know that e power log x is, again we can write x since the base is same. And now the general solution y into integrating factor, that is x, is equal to integral of sin x into integrating factor is x dx. So let us find x sin x by using the by parts. Say this is first function and this is second function. So we can write xy is equal to x into integral of sin x dx minus integral of differentiation of x is 1 into integral of sin x. Let me write stepwise. D by dx of x into integral of sin x dx and the whole dx. So we can write xy is equal to x into integration of sin x is minus cos x minus integral of differentiation of x is 1 and integration of sin x is minus cos x. So which can also be written xy is equal to minus x cos x, and integration of cos x is sin x, so minus of minus plus sin x plus constant c, or we can write xy plus x cos x is equal to sin x plus c, or x taken common, y plus cos x is equal to sin x plus c. So we can go with an option C. Given that the solution of dy by dx is equal to ax plus h upon by plus k represents a parabola. So we need to find the conditions for A and B. So given dy by dx is equal to ax plus h upon by plus k, which implies that by plus k of dy is equal to ax plus h of dx. So further we can write, or integrating on both the sides, integral of ax plus h dx. So we can simplify and write b times integration of y is y square upon 2 plus integration of 1 dy is ky is equal to integration of ax is a into x square upon 2 plus hx plus some constant c. So here we can write a upon 2 x square minus b upon 2 y square plus hx minus ky plus c is equal to 0. When comparing the equation with ax square plus by square plus 2gx plus 2fy plus 2hxy plus c is equal to 0, the second degree equation represents a parabola for the condition h square is equal to ab and delta is not equals to 0, that is discriminant. So here we can consider h square is equal to ab, so there is no xy term, so h is equal to 0, and here we can add a is equal to a upon 2 and b is equal to minus b upon 2. Since h square is ab, so a upon 2 into minus b upon 2 is equal to 0. So which implies ab is equal to 0. Either a is equal to 0 or b is equal to 0. Any one of them can be 0 or both can be 0. So here a and b both cannot be 0. If both are 0, a is 0, b is 0, it will become a straight line. So it is not a parabola. So we can consider either a not equals to 0 and b is equal to 0, or we can consider a is equal to 0 and b not equal to 0. So we can go with an option C. So option C is one of the condition we have to represent parabola. We need to find the solution of the differential equation dy by dx is equal to cos of x minus y. So let us simplify it by taking, put x minus y is equal to t, so that we can on differentiating we'll get 1 minus dy by dx is equal to dt by dx, or we can write dy by dx is equal to 1 minus dt by dx. So here we can write 1 minus dt by dx is equal to cos of t, or 1 minus cos t is equal to dt by dx. Now simplifying, 1 upon 1 minus cos t dt is equal to dx, and we know that 1 minus cos theta formula is 2 sin square theta by 2. 1 upon 1 minus cos theta is 1 by 2 cosecant square theta by 2. So here we can write 1 by 2 cosecant square t by 2 dt is equal to 1 dx, and integrating on both the sides we'll get 1 by 2 integration of cosecant square is minus cot t by 2, and here the coefficient of t is 1 by 2, so we must divide with 1 by 2 here, and which is equal to x plus c. 1 by 2 1 by 2 gets cancelled, so we can write minus cot t by 2. T is nothing but x minus y, so we can substitute x minus y upon 2 is equal to x plus c, or we can write x plus cot of x minus y by 2 is equal to constant c, so which is option B. So we can go with an option B. We find the general solution of x square into dy by dx is equal to 2. So which implies dy is equal to 2 upon x square into dx, and integrating on both the sides, integration of 1 dy is y is equal to 2 into x to the power of minus 2 plus 1 upon minus 2 plus 1 plus c, that is y is equal to 2 upon minus 1 x to the power minus 1 plus c, or y is equal to minus 2 upon x plus c, which is option B. C minus 2 upon x. We can go with an option B. Find the integrating factor of differential equation cos x into dy by dx plus y into sin x is equal to 1. So this can also be written dividing with cos x. So we'll get dy by dx plus y sin x upon cos x is equal to 1 upon cos x. So which can be taken dy by dx is equal to y in dy by dx plus y into tan x is equal to secant x. It is in the form of dy by dx plus p of x into y is equal to q of x, and its integrating factor if is equal to e to the power integral p of x dx. So here we can write integrating factor is equal to e to the power of integral p of x. P of x is tan x here dx, which is equal to e to the power of integration of tan x is log mod of secant x, and here we can say the base is same, so we can write directly secant x. So we can go with an option A. We need to find the solution of the differential equation dy by dx minus y tan x is equal to minus y square secant x. So let us divide with y square. So we'll get 1 upon y square dy by dx minus y upon y square into tan x is equal to minus secant x. So this can also be written 1 upon y square dy by dx, or we can also take in common minus. So minus plus 1 upon y into tan x is equal to secant x. Let us substitute. Put 1 upon y is equal to t. So you'll get minus 1 by y square dy by dx is equal to dt by dx. So we can write minus 1 by y square dy by dx can be taken as dt by dx plus 1 upon y, that is t into tan x is equal to secant x, which is in the form of dt by dx plus p of x into t is equal to q of x, and hence its integrating factor e power integral p of x dx, and general solution y into, that is t into integrating factor is equal to integral of q of x into integrating factor dx. So here we can write integrating factor is equal to e to the power integral tan x dx, that is e to the power of integration of tan x is log secant x which is equal to e to the power of log secant x can be taken as secant x. And general solution, so we can write y into, that is t into integrating factor, that is secant x, is equal to integral of q of x. Q of x is here secant x into integrating factor secant x dx. So we can replace it back. T is nothing but 1 upon y. So 1 upon y into secant x is equal to integration of secant square is tan x plus some constant t. That is, we can also write 1 upon y is y power minus 1. Secant x is equal to tan x plus c, which is option C. So we need to find the solution of the differential equation x power 3 dy by dx plus 4x square tan y is equal to e power x into secant y, satisfying that y at 1 is equal to 0. That is, at x is equal to 1, y is equal to 0. So let us take the differential equation x power 3 dy by dx plus 4x square tan y, we can write sin y upon cos y, is equal to e power x into secant y, we can write 1 upon cos y. Or we can also taken, it can also be taken as x power 3 into cos y dy by dx plus 4x square into sin y is equal to e power x into cos e power x. After simplifying, you can remove cos y. Then we know that x power 3 differentiation is x square and sin y differentiation is cos y. And if you can see, x power 4 sin y differentiation, d by dx of x power 4 sin y is equal to x power 4 into cos y plus sin y into differentiation of x power 4 is 4x power 3. So x power 4 cos y plus 4x power 3 sin y. So let us multiply both the sides with x. So you'll get x power 4 cos y dy by dx plus 4x power 3 sin y is equal to x into e power x. And here we can see that x power 4 cos y dy by dx, here dy by dx will come, plus sin y into 4x power 3 is nothing but d by dx of x power 4 sin y is equal to x into e to the power of x. And on integrating d by dx of x power 4 sin y is equal to dx is equal to integration of x into e power x dx. So in differentiation of integration, we can write directly x power 4 into sin y is equal to x into integration of e power x is e power x minus integral of differentiation of x is 1 into integration of e power x is e power x plus some constant, that is x power 4 into sin y is equal to x into e power x minus e power x plus c. And it is given that x is equal to 1, y is equal to 0. Substituting, so here we can put x is equal to 1, y is equal to 0. So we'll get 1 power 4 into sin 0 0 is equal to 1 into e power 1 minus e power 1 plus c. So sin 0 is 0, 0 is equal to 0 plus c, so which implies c value is 0. And hence we can write the equation x power 4 sin y is equal to e power x taken common x minus 1 plus c. Or we can write sin y is equal to 1 upon x power 4, that is 8 x to the power of minus 4 into e power x into x minus 1 So we can see the option B. Option B is the answer. The degree of the differential equation of all tangent lines to the parabola y square is equal to 4x. So for parabola y square is equal to 4x. So let us consider one point. The tangent equation at this point having the slope m, we can write y is equal to mx plus a upon m. We can write here condition for the straight line y is equal to mx plus c to become a tangent for parabola y square is equal to 4x is y is equal to mx plus a by m. So let us consider this is a tangent line. So and we know that this m is nothing but differentiation at this point. A slope m is nothing but dy by dx at the point we can mention, and hence we can write y is equal to dy by dx at a point into x plus a upon dy by dx, or we can write y into dy by dx is equal to dy by dx whole square into x plus a. So here it is a differential equation and the order is only 1, dy by dx, and the power of the order is 2. So we can say the degree of the differential equation is 2 with the order 1. So we can go with an answer degree of differential equation is 2, option B.